8, I think, or something like that. So I think we got it, right? We get it? Okay, cool. I added another one in there, just the connection piece of it. So if you connected to a, even like a lesson that we did, that'd be cool. So there's a little connection, but we'll talk about it Monday as we have more time. Hopefully more people here. So let's go with it here. So on this one, I said last time, what you want to do is you want to solve for the biggest angle that you're going to have. So this one I think is fairly fine. We got a 13, 14, and 15 angle. So let's draw our non-scale triangle. ABC. And looks like A is 13, B is 14, C is 15. So what we're going to do is we're going to solve for that one right there. No problem, beach bum. Yeah, no one's here. I know, everybody.
Yeah, where is the husband here?
I don't know why he wouldn't be.
So we have variations here. So in your textbook here, I think you have both of them. Let me check. So I have the law of cosines. And you have both variations. So since we're solving for the angle and it's angle C, I'm going to go like this. Cosine of C is going to be this little equation right here. It's going to be a squared plus b squared minus c squared all over 2 times ab. And we're using the law of cosines just to get us back to the law of sines. Once we get an angle on its opposite side, we can use the law of sines again. We could just keep on using the law of cosine, and that's fine too.
Sorry, my stuff on a very slow school bus.
No problem.
All right, those just came in. We are using something called the law of cosines. And so a little bit different formula. If you look in your textbook, it's like right down here, cover right over here. There's 2 different kinds. There's one where we look at the angle and we're trying to find the side. This one, we're looking at all the sides and trying to find an angle. And we want to get the biggest angle possible first. If we have time, we'll look at it here, because the law of sines, it only works from 0 to 90 degrees correctly. And so you don't want to find an angle that's greater than 90 degrees using law of sines. It does not work. All right, let's plug stuff in, see what we get to here. So A is 13 squared plus 14 squared minus 15 squared all over 2 times 13 times 14. And it's a monster, plug it into your calculator. So let's do this here. See if you guys can put that into your calculator. Once that is all said and done, then just take the cosine inverse of all that. Let you guys try it yourself. Make sure you're in degree mode as well. That'll be kind of helpful. And go for it. Let's see, a few things here. You want to put parentheses around this piece right here, or else you'll just be dividing by, you'll be dividing the 15 squared only. So extra parentheses there. And then you want to divide by all that. So maybe an extra parentheses here. So plug it into the calculator, it probably looks something like this. Start it with a parenthesis, you go 13. I think you do have a little squared button on your calculator. Do you have a little squared button on your calculator? Makes it a lot easier than putting that little caret symbol and then 2 and all that stuff. So plus 14 squared minus 15 squared, close it off, divided by, and then you need another parenthesis here. It's going to be 2. Ooh, that's fun. That's the first time that happened. Times 13 times 14. Boom. And what do you get approximately?
I got 0.384.
84. Remember, this number should be between -1 and +1, right? Or else we did something wrong. Nicholas?
I just had a quick question because A is 13 feet and B is 14 yards. They're supposed to be the same.
Oh, sorry. Yeah, that'll be good. Let's put everything into feet. Or yards. Hold on. How about that? Thank you so much. Or else it will not work. Okay, On your calculator, keep that answer and let's take the cosine inverse of that. So let me jump to a calculator just real quickly here.
That's incredible.
Still, the question is, where's your B?
I basically gave up on it today. I was like,
Yeah, I think I
You
was.
know, they got a water for me.
I was
I
like,
didn't
I'm
really
too
work with
tired.
Baxter Boy either, but okay.
You're my slight frat boy at the beach, right?
Yeah.
Yes, this is what I actually work in. Anyone, you know, you've seen.
I have seen you. I've seen you before, you're right.
Whoa, really?
Crazy.
Wow.
You can see me. I've never looked at your eyes.
Wait, you're not
Lucky.
lucky?
Oh, it's very little.
That is a very small calculator.
67.38.
Can I even get it? No, I can't.
Nice.
It disappears. Oh, that's funny.
But it's so sad. It's so small.
You know when you think about it, it's like this.
He's like, fine, you can have a calculator. There you go.
Oh, it's still small.
Type it in. Oh, no. Oh, yay. Oh.
It has come back. Wow.
It was tiny.
Jamming. Okay, real quickly here. So 13 squared. Oh, I'm doing it wrong, of course, here. Parentheses, 13 squared. There's my little square button. Plus 14 squared. Minus 15 squared. Inside this little parenthesis itself, just to keep the top separate from the bottom. And then 2 times 13 times 14. Almost there. Guys, are we good? Yes, all right, we're right. So cosine inverse, let me check my mode here. My mode is in radians, of course, change to degrees, or else it will not work when I do this. And how about cosine inverse of, and what we're gonna do is we're gonna plug in our previous answer. If you are going to write it down and put it in, you probably wanna go maybe 4, 5, or 6 decimal places, because you want to have a little closer approximation. And if you're off by just a little bit, maybe like by 1 degree on here, it's fine. You did it right. Don't worry too much about that. Let's go with it.
How many places is the 0.38 number? 2. How many do you write down?
If you're gonna write it down, probably write down 5 decimal places, just to make sure you have some accuracy there. So 0.1, 2, 3, 4, 5.
4, 6. Except it'd be 2 because there's 5 after it.
Sure, yeah. 4, 6, 2. All right, I would do this all in one take on a calculator though. I would just go cosine inverse and then click my answer button right here. So I don't have to write it down and then plug in the value itself. And we're good to go. Hey, that's still pretty good. Then the question becomes, is it just 67, 67.4? Generally speaking, I think we go to the nearest degree if you're not given degrees. But look in the back of the book, if you see like, oh, they take it to the 10th. Okay, that's fine. I can take it to the 10th too, or you can just say, I'm gonna keep it, understand I'm doing it correctly here. So 67 degrees, let's go with that here. Boom. Okay, now, do I have an angle on its opposite side?
Yes.
I do. Okay, so I'm going to use this because the law of sines is a little bit easier than the law of cosines. So go for it, anyone that we like. Let's go B next. So sine of B over 14. Or, yep, is going to give us sine of 67 over 15. Ooh, much easier to use. Let's see, I'm going to multiply the 14 on this side. All right, and then again, sine inverse of all that again. So same exact concept. Find what that is first. And let me just do a calculator one more time, and then I'll let you guys do it. Unless you have a question in the calculator, I will presume you guys are doing it correctly here. So to do 14 times sine of 67 degrees, enter, let's see, divide by 15. There's that. Sine inverse of my previous answer. Voila. Are we okay with that? 59. Bless you. all that in there. 59 degrees is fine by me. All right, total choice here. So let me go back to our previous slide here. I have this is 59. Talk to me, what should I do? Perfect, yeah, now we have choices here. We could do another law of sines if we like for A, or we can just add them up, divide from 180. So this guy is just gonna be 180. I like to do this on the calculator. I like to go 180 minus 67 minus 59. And what is that? 54 is good and done. Okay.
What is the hardest way to find 3? Like, what is the most difficult, painstaking, tedious way to find it?
For Matthias, it's going to be the law of cosines again.
Yeah.
Like, hey, let's do the law of cosines again.
Nice, very
And
cool.
you can probably prove the law of cosines before you solve, just like every time you use it, just prove it to make sure it still works. If you
Yeah,
want to just do
that's
it more
true,
time.
yeah.
Just do it
To make sure reality
Yeah.
doesn't change.
Sure.
Lining with Matthias.
Or make sure, yeah, Matthias hasn't changed
I
reality.
have lost
Yeah.
cosines 5 times.
This is like his
just to make
third
sure it's the right
dimension.
answer.
Yeah.
This week.
You do that with us.
He used to
Let
be
me know.
2D, but now he's moved on to 3D.
You're right.
Maybe someday he'll be able to move through time too, like stationary in one moment.
No, well, he switched with Backstreet Boys.
Oh, right.
For Wednesday.
Okay.
And now he's switching with Beach and Thighs. The one that wears shorts.
I think an alternate dimension where Earth is just a beach. All of it.
Or just you as a person just made the choice to never leave the beach.
I just built a campfire by the water.
Yeah.
And I'm just figuring it out always.
And he's still that pale. It's crazy.
All right, let's jam. Let's see. One application question, navigation.
Oh, no.
We did it with the law of sines as well. You guys remember where the wind, we were not sure which direction the wind was coming from. So it was either making us go faster.
That's what I figured out.
Say again?
If you want to find out which direction the wind is coming from, you can
The finger, there you go. Yeah, that helps.
That made it simple.
Yeah.
All you have to do is
The finger.
Yeah.
Go for it. Yeah, look at first. Yeah. Okay. So let's jam with it here. Here it is. So just a example here. So ground speed. So we were talking about here's airspeed of an airplane or something. Yeah, airplane here. Sorry, ground speed. So you have airplane going this way here. You got a wind that's actually pushing it this way. So then really ground speed or true speed of the airplane is down here. It works with boats as well because of currents in water. Not so much in rivers. Rivers, what would happen in rivers is usually like the Mississippi River. You have a boat going downstream will take less time than going upstream because of the flow of the water. So it's almost like one direction. The flow of water either adds to the speed or goes against the speed.
Go off course in a river. Like the river's going one place.
Right, yeah. So you don't have all these angle measurements here.
Darn,
There.
which way is the river going?
Like if you're
I
using the
don't
river,
know.
you better want to go to where the river ends up.
Okay, so let's jam with it. Here's this one here. So a plane is flying with airspeed of 185 miles per hour, heading 120 degrees. The wind current are running at a constant 32 miles per hour at 165 degrees clockwise from due north. That's how we measure it here. So find the true speed of the airplane. So I'm going to go with this one here. So drawing this out like this. This is true north, south, and then we're going to go with 100. So we always go from true north this way here. So 120 would be about maybe like right here. And what we do is we just put how many miles per hour it's going. So it's a vector, or we can say it's just the magnitude of it. All right, 165 degrees would be a little further. It would be about what? It would be like this way, right? It would be this way here. Okay, the other thing is what we do is we here's our little issue that we do here because we want to tack this on to the next one, right? And so 165 would be about something like this. True. If you guys agree there. And we're tacking on to the next or the previous view of the airplane here. So this piece right here will be 165 degrees as we're trying to connect them from one end to the beginning of another one here. So looks like we're going to try to get to this piece right here. So give me the true course. This one's 32, we know that for sure.
Oh, I was so confused. I thought we labeled the angle, the 120 angle as 185. And I was like, how is angle 185 smaller than 165? What am I doing?
You decided to assign new values to those numbers.
All right, let's see. What is there an angle that we can find out? Guess that's the next question.
No, we're done.
We're done.
Oh, that's unfortunate.
We broke trig.
Yeah.
So let's see. So first, if this is 165, this little piece right here, would that be 15? Right, that gets us to 180, right?
Oh, yes, okay, I see
Okay.
what's happening.
Well, that's not.
And then
even
it's
true.
alternate
It's
interior,
just
so the other part is
actually-
120.
Yeah, it is.
Okay, so then, yeah, from geometry, sorry, to dysregulate you guys again here. So remember transversals, right? We have two parallel lines coming. So that means this right here would be 120 degrees. I like this then.
135.
Yep, so if I'm gonna redraw this, something looks like this right here, right? We have 185 here. We have 120 plus 15, which is 135. And then we have 32. I guess question is, can we solve this by using the law of sines?
No, because we don't have angle on the opposite side.
Uh-huh.
Tragic.
Boom. Okay, so this is again a SAA relationship, right? That's the one that's used for. So we could go for the true ground speed right now. We just have to label this here. So label it ABC, however you want here. So ABC, I'm gonna label it like this. And so I'm gonna label this as little c. So the formula I want, hey, it's the same formula we did before. So all yours to try it yourself here. Cosine of c is equal to a squared plus b squared minus c squared over 2 times ab. All right, all yours, go. Oh yeah, and some beach music. There you go.
You tell them to wait out there all day.
Jumps out.
Wait, but don't we know angle C?
We do not know angle C. It's this little extra piece here that will give us.
Isn't that side C?
Oh no, we know angle C. We don't know side C. Oh, thank you so much. The wrong formula.
Yeah, I was gonna say so.
Side C is equal to a squared plus b squared. Finish it off for me. I think it's 2.
Yeah, AB cosine C.
AB cosine C. Thank you. Okay. This guy is going to be 32 squared plus 185 squared minus 2 times. Okay, and then try this on the calculator as well. See if you guys punch it in. Let's see if it the TI will actually do both of them or all of it all at once here. 135 degrees. And that's gonna be c squared, well, then we have to take the square root of that. All right, I need, let's see, some people to give me the answer and others to agree. No, bless you, bless you. Not just to agree, but actually to see if you did it correctly too here.
I got 208.9.
Sounds about right. Seems like C is going to be longer than both of them combined, right? Since they're going different direction here. Okay, we good there. Anybody okay doing it on the calculator? Anybody need help on the calculator? You are still going to take a square root of it though at the end.
Like mathematically, that doesn't seem like.
C should be the longest side. Let's see, but it's going to be less than the addition of those two.
Yeah.
Yeah, so let's see. It can't be bigger than 217. If it's more than 217, then we don't have a triangle. Okay. Talk to me.
Yeah, I
Sure.
got the same thing. Let
It's
me
okay.
try it again.
Doing a calculator? Are you guys okay? Did everybody get the correct answer? Those trying it on the calculator.
Very close to before I believe it, but
What was it?
208.9. Rounded.
208.9, is that what you
Mhm.
Let me do it for people watching the video here. How about that? Talk to me. I can't see what I'm supposed to enter. So
32.
32, thank you.
said? Plus 185 squared minus 2 times 32
Mhm.
times 185 times cosine 135.
Thank you. Okay, big number. And then we have to take the square root of that number still. And 208, so 209, 2089, I guess, yeah. 2089. This is miles per hour, right? That's how fast it's going. Okay, another thing that we got to do is, that's only one part. I still have to figure out the angle it's going. So it's not only angle A, but it's also this whole piece right here. It's the angle from true north. That's what I need. But at least for now, let's find this guy out right here.
Find what out?
We're going to find out this right here, the angle of A. But our final answer is going to be what's the angle from true north all the way down. That's what we wanted to see. So I think I can put it right over here. How about this? Sine of angle A over 32 is equal to sine of 135 over 208.9. Okay, doing that and then taking the sine inverse of it. Anybody with that answer?
Don't know if this is right, but I got 6 degrees.
6 degrees, sounds about right. Anybody else can try it? Make sure in degree mode. Verify that one. Nope, no one else wants to try it. Okay. It's beach day, Mr. Ng. Come on.
Who brings a calculator to the meeting?
It's really funny.
Brandon,
Almost.
Laugh.
go to the bad points.
135 divided by 208.9. Okay, good there. And then sine inverse of all that little good stuff there. Okay, go with that. 6.2 maybe. Let's see, about 6. No, it'll be 6 because the angle measurements are in that way here. Okay, I got 6 degrees. Talk to me. What is the true degree value that it's headed?
126.
I'll go with that. Yeah, it's this little 120 here, still from the original one. Then we add an extra 6 in here. So this guy is heading, I'm running out of room here. How about 208.9 miles per hour at 126 degrees. Boom, are we good there? Interesting. And I'm pretty sure you're never going to have to calculate that in real life.
Not unless you become
Let's just
whatever
take
it's
a class
called.
tomorrow.
I'm gonna use this in the real world.
That's
You
what
guys
the
can have whatever
presentations are
jobs
for.
There you go.
What do you mean that already was?
Now, the person that actually programs the autopilot probably needs to make sure of this, right?
Yeah.
And the person that's actually doing that. Okay, one more example here. And we got this guy. Anybody seen one of those little devices?
Oh, is
Driving by?
it
Geo-
Geo?
Let me guess, he's surveying.
It's a surveying tool,
Okay.
I don't know the exact name of it here.
So the thing that shoots a laser out.
There you go, yeah, shoots a laser out, comes back and tells you the distance right away.
If he's a surveyor, can he do the
No, of
process?
course.
Yeah, he's more
Let's
qualified.
call him up.
It's-
And then the CIA.
We'll have to help him out, he needs help.
Okay, fire him.
Yeah.
Not help in a high school class.
These things are actually pretty cool.
Does he look like he has a high school education?
Oh,
Okay, you got
profiling by
fired.
Grant, oh, man.
Construction is the like,
What? I mean, I would like that since they're constructing buildings, I would like that.
Yes. Wow.
I have dissolved the thin veil of society with a single comment.
No.
Incorrect.
Who am I science it is? It is thinking. Okay, besides that, this little nifty tool is pretty cool because usually there's 2 people working, and usually you have stick man holding this guy, and this is just a reflector. And the reflector is just for the laser going back and hitting back, right? Because if the laser keeps on going forward, it just keeps on going forward, right? But what you do is you shoot a laser from here to here. It hits, comes back, and by the time it comes back, it tells you how far or the distance you are away, right? And then what happens? You swivel this thing, and as you swivel, right here somewhere or on the backside, whatever he's looking at, usually it tells you the degrees that you just turned. So you have initial degree, that's going to be 0 once you click that button, and then once you start turning it, that'll tell you a degree. And then what you do is you click again to get that distance. So right away you have a side angle and you have a side. It is pretty cool. So let's jam with it here. So we have this right here. Surveyor measures. We're going to measure the length of a lake. Not too, maybe like a pond, maybe like a little small marsh at this point. So we got a surveyor person right here. All we do is we're going to have another person standing with the reflector on this side. Or he planted it over there, just walked over here to his device.
So is C at an angle? I was thinking it was underneath the water. And
Yeah.
How?
Gotcha,
did it
okay.
get down
Sorry.
there?
Yeah, it's away, sideways away from the water.
That would work. I'm just not sure why. You would have to drain the water.
Well, yeah.
Or have a waterproof tool.
We're gonna survey your lake.
And a diver.
Have to drain it. I hope you guys don't mind.
It's like a swimming pool, right?
But technically.
Sure,
By
yeah.
those angles, it would still work. for
Yes,
that
it actually would still
location.
work.
You would just have to be underground.
So this is like when I was talking about the most painstaking way you could do something.
Yeah.
This is the equivalent.
You will definitely not do this in real life.
This will be my presentation. So, when you have to
Light bulb
survey
up there.
a pond and you have to drain the
Yeah.
water.
Wait, that's actually kind of a cool presentation. What is the hardest way to do the simplest trig problem?
Yeah, no, not the best real world uses of trig.
Right, yeah.
But it's
Ways you will
fun.
never
Please
use
do
trig.
that because that would be
I
really
will do that.
interesting.
Anti-application.
And that'd be so Matthias too.
Yes.
Yeah.
Here's all the things that trigonometry will not help you with.
My presentation will be, this is the problem you will do in class, which is real life. Not all right now.
Smart. Nice.
That's cool.
It's gotta be something you're never gonna do in class.
Well, yeah.
Well, you have to get it wrong.
And that's it.
Okay, let's go with it here. So above the ground, we're gonna go with the measuring from here to here is 150 feet. And he had to walk. Let's make it with just one person. So he planted this little guy here. He walked over here. He put his device down. He walked over here. He planted the other one, walked back, measured this way to be 150 feet, swivel this, and we swiveled it. It turned out to be 115 degrees. And then he took this side and found it was 100 feet exactly. There it is. Question is, does he have enough information to figure out the length of the lake? With the law of cosines, yeah.
No.
I believe on the instrument panels, the newer ones, the newer versions, you actually just click on which one you want, right? And it actually does the calculation for you here.
Wait, so why does he need help?
I don't know, you guys are just offering it out.
His little tool broke.
Oh, ouch.
It just broke his in about calculating.
There's little tool, including the internet, bro.
Yeah.
Yeah, don't worry, his laser power. That still works, yeah.
Anyway.
Anyway, yeah, let's go with sine squared is equal to.
There are only surveying tools.
Yeah, there's no calculator, no internet.
There is only surveying.
All right, plug into that one if you guys can.
And they're all old.
There'd be quite a dystopia.
They're all like 30 years old.
Yeah. They're on like ovens or like TVs. It's just serving. No other form of technology.
We just stuck a laser in our eyes.
The only form of technology to survive is surveying.
For some reason, we're super.
But it's
concerned
really
about
outdated.
measuring a bunch of stuff.
Well, we have nothing else to do.
Back in my day, we didn't have television.
The
We had
problem is,
lasers, which we
The
stuck
surveying
in.
tools are all very outdated.
So you can't cook anything with a laser because it's.
So the
tiny as a
people
laser.
who took a semester and a half of a high school trigonometry class have to help.
Yeah. Save the day. Application follow. There's my presentation.
We will bring Western civilization to these savages.
I think this is our future.
Yes.
Yeah, precisely.
Maybe instead of doing presentations on something that's applicable today, something that will be applicable in the future.
Exactly.
And then, like,
So you can do literally anything.
Thousands of years.
Or
in the
nothing at all.
apocalyptic
I got
future.
Yeah.
200.
Space travel involves.
Well,
Say again?
212.
That's about right. Yeah,
Sure, if I
here,
made something up about how it
212.
applies to something in space, I can just use any problem.
Okay.
Yeah, oh my gosh, that's so interesting.
Yeah.
Yeah, you
I don't
gotta
know,
calculate the ground speed and the true course in space.
Or you have to, or calculating warp speed. Warp
What?
speed, if
Oh
you're
no, what
gonna
someone
be
should
here.
do for their presentation is find like the most obscure problem that like doesn't seem to apply to anything, but then make up a scenario for the future where this would apply.
Yes.
That would also be a good one.
Be like, this is gonna happen in 40 years, so you should all
You have to
be
like
taking
map out
notes.
things from movies.
Your grandchildren are gonna know this, so you need to know it, okay?
You just pass down those notes.
Interstellar.
And then when it happens, we'll all be like,
Use all
It turns out that the person doing the
no,
presentation like did the
11.
calculations wrong or something.
existing movies.
All right, guys, 212.5, are we good?
Trigonometry.
Can I get a second on it? No, there's only one person doing a calculator, so.
do you want me to do it again? Okay, I'll try
We're
one
good.
more time.
No, we're good, Amanda. I think it
Yeah, okay,
sounds
let's
about right.
Yeah.
All right, we get a second, okay. Cool, class, we're done. We're done with 7.3, so enjoy the rest of your beach day
Iterations of it, so.
Yeah, like you have to include like
and the rest of your life too.
All the random books.
yeah. all the- Like going to the zombies.
So,
What, how
just
can we
remind
go-
me-
Yeah.